It's a question that pops into your head late at night, or maybe when you make a choice and you wonder about the road not taken. What if I hadn't missed that train? What if I had said yes instead of no? Is there another me somewhere out there living that other life? And if there is, could I ever see them? Could we ever peek into that other world? The idea of a parallel universe isn't just for science fiction. It bubbles up from the deepest, strangest corners of modern physics. And it's a possibility that serious scientists, people with very big brains and complicated chalkboards, actually consider. They don't call it the upside down or a mirror world, they have other names for it. The multiverse, other branes, quantum foam. But it all boils down to the same basic idea. Our universe, the one with Earth and the Sun, and an alarming number of reality TV shows, might not be the only one. There could be others. An infinite number of others, maybe. Some could be almost identical to ours. Others could be so wildly different that we couldn't even comprehend them. So the big question is, if they're out there, could we see them? The simple, honest answer is probably not. At least, not in the way you see things in a movie. You're not going to open a shimmering portal in your closet and walk into a world where dinosaurs still roam. You're not going to look through a telescope and see another version of yourself waving back. The reasons why are baked into the very fabric of reality. But the story of why it's so hard and the few faint possibilities that might exist is where things get really interesting. To understand how we might see another universe, we first have to understand what these universes are supposed to be. There isn't just one theory. There are a few big ones, and they each suggest a different kind of parallel world. The first one comes from quantum mechanics, the physics of the very, very small. It's called the many worlds interpretation. It's a mind-bending idea. It says that every time a quantum event has more than one possible outcome, the universe splits. Both outcomes happen. They just happen in separate, newly created universes. Think of it like this. You flip a coin. In our world, it lands heads. According to many worlds, at the exact moment of the flip, the universe split in two. In one universe, our universe, it landed heads, but in another, brand new universe, it landed tails. There is now a version of you in that other universe who saw it land tails, and this happens for every single quantum event, all the time, everywhere. It's happening trillions upon trillions of times a second. This creates an infinitely branching tree of universes. There's a universe where you got that job, a universe where you didn't, a universe where you woke up 5 minutes earlier this morning. A universe where Earth was wiped out by an asteroid a million years ago, a universe where your socks are a slightly different shade of blue. Everything that can happen does happen, just in a different branch. But here's the catch with the many worlds idea. Once those universes split, they are sealed off from each other. They no longer interact. The math behind it says they become decoherent. That's a fancy way of saying they can't see or touch or influence each other ever again. So, according to this theory, the answer to our question is a hard no. There is another you out there. An infinite number of them, in fact. But you can never ever see them. They are forever beyond your reach, living on a different branch of reality. It's a lonely kind of infinity. Then there's a different idea which comes from cosmology, the study of the universe as a whole. This is the bubble universe, or multiverse theory. It suggests that our universe is just one bubble in a vast, bubbling, cosmic soup. Imagine a pot of boiling water. Our universe is one of those bubbles that formed and expanded. But there are other bubbles constantly forming. Each of these bubbles could be a whole universe. And crucially, they might not be like ours at all. The laws of physics could be different in each bubble. In one, gravity might be much stronger. In another, there might be no such thing as electricity. In another, there might be 4 dimensions of space instead of 3. Most of these bubble universes would be sterile and dead, unable to form stars or life. But in a big enough pot of boiling water, you're bound to get a few bubbles that have just the right conditions for things like us to exist. This idea is a bit more hopeful for our question. If our universe is a bubble, could it ever bump into another bubble? What would happen if it did? Some physicists think that maybe, just maybe, this has already happened. And it might have left a mark, a kind of cosmic bruise. To look for this bruise, we have to look at the oldest light in the universe. It's called the cosmic microwave background, or CMB. It's the afterglow of the Big Bang, a faint radiation that fills all of space. It's like the baby picture of our universe. When we look at this picture, it's incredibly uniform. The temperature is almost the same everywhere, but there are tiny, tiny fluctuations. And in one part of the sky, there's a spot that's just a little bit colder than it should be. It's called the CMB cold spot. Nobody is sure what it is. It could just be a random fluctuation, a statistical fluke. But one exciting out there possibility is that it's the scar, the remnant of a collision between our baby universe and another bubble universe billions of years ago. We wouldn't be seeing the other universe directly. We'd be seeing its ghost, a faint fingerprint it left on our own reality. Scientists have looked for other signs that would support this, but so far the evidence is thin. It's a tantalizing clue, but it's far from proof. It's a maybe. A cosmic what if. A third idea comes from something called string theory. String theory is an attempt to unite all the forces of physics into one theory of everything. It's incredibly complex and not yet proven, but it has some fascinating implications. One of them is that there are more dimensions than the 3 of space and 1 of time that we experience. There could be 10 or 11 or even more. So where are these extra dimensions? The theory suggests they are curled up, incredibly small, so we don't notice them. But another idea within string theory is that our entire three-dimensional universe is just a membrane, or a brane for short, floating in a higher dimensional space called the bulk. Think of a loaf of bread. Each slice is a universe, a brane. The whole loaf is the higher dimensional bulk. Now, imagine we are tiny creatures living on the surface of one of those slices. We can move around on our slice forward and back, left and right. But we can't perceive the other slices. They are right there, less than a millimeter away, but they are in a direction we can't access. They are in the third dimension of the loaf, while we are stuck in our two-dimensional slice. This is the brane world idea. Our universe is a brane, and there could be other branes, other universes, floating parallel to ours in this higher dimensional space. They could be incredibly close to us, maybe just a millimeter away, but we can't see them or touch them because we are stuck on our own brane. Almost everything is stuck. Light is stuck. Matter is stuck. The forces that hold atoms together are stuck. That's why we can't just reach out and touch this other universe, but there might be one exception. Gravity. Gravity is weird. It's a fundamental force of nature, but it is shockingly ridiculously weak compared to the other forces. Think about it. A tiny little refrigerator magnet can lift a paperclip, defying the gravitational pull of the entire planet Earth. Why is gravity so feeble? The brane world theory offers a possible explanation. What if gravity isn't stuck to our brain like everything else? What if it can leak? What if gravitons, the hypothetical particles that carry the force of gravity, can travel between the branes through the bulk? If this is true, it would mean our universe is constantly losing a little bit of gravity into this higher dimension, which would explain why it seems so weak to us. It also gives us our most plausible way of seeing a parallel universe. We wouldn't see it with light. We'd feel it with gravity. If another brane, another universe was nearby, its gravity could leak into our universe. We might see its gravitational influence. We could see a star in our sky being tugged by a star we can't see, one that exists only in that other universe. We could see a galaxy cluster whose mass seems to be much larger than the sum of its visible parts, because we are feeling the gravity of a shadow galaxy on a parallel brane. This even connects to one of the biggest mysteries in cosmology, dark matter. We know there is a huge amount of invisible matter in the universe. We can see its gravitational pull on stars and galaxies, but we have no idea what it is. One very speculative idea is that dark matter isn't matter in our universe at all. Maybe it's just normal matter, like stars and planets, in a parallel universe right next to ours, and we are just feeling its gravity leaking across the dimensions. This is something scientists are actively looking for. At places like the Large Hadron Collider, they smash particles together at incredible speeds. They carefully measure what comes out of these collisions. If brane world theory is right, sometimes a collision might produce a graviton that flies off our brane into the bulk. This would look like energy and momentum suddenly disappearing from the experiment. It would vanish without a trace. If physicists ever consistently saw energy vanishing in a very specific way, it could be the first piece of experimental evidence for extra dimensions, and for the existence of other branes. So far, they haven't found anything conclusive, but they are still looking. So we have a few theoretical ways to see another universe. We could look for a cosmic bruise in the CMB, or we could look for the gravitational whispers of a nearby brane. These are not direct observations, they are indirect clues, shadows on the wall of our cave. But what about a more direct way? What about a doorway? This brings us to wormholes. Wormholes are a staple of science fiction, but they have a real basis in physics. They are a potential solution to the equations of Einstein's theory of general relativity. A wormhole is a theoretical tunnel, a shortcut through space-time. It could connect two distant points in our own universe, or potentially it could connect our universe to a completely different one. If you could create a stable wormhole and walk through it, you could, in theory, step into a parallel universe. You could see it with your own eyes. But the if in that sentence is doing a lot of heavy lifting. The problems with wormholes are immense. First, if they exist at all, they are likely to be subatomically small, far too tiny to send anything through. Second, they are predicted to be incredibly unstable. They would snap shut in an instant, probably before even a single photon of light could get through. To keep a wormhole open, you would need something called exotic matter. This is stuff that has negative mass or negative energy density. We don't know if such a thing can even exist. It's a theoretical concept that pops out of the math, but we have never observed it. To build a human-sized, stable wormhole, you would need a vast amount of this hypothetical stuff, perhaps the energy equivalent of an entire star. So while wormholes are a mathematical possibility, they are a practical impossibility with any technology we can imagine. They are probably not our ticket to another reality. They remain, for now, firmly in the realm of fiction. This brings us to the core of the problem. The universe puts up some very big walls between itself and any potential neighbors. The first wall is energy. The energies required to probe these other realities, to create a tiny wormhole or to peek into an extra dimension, are colossal. They are energies we haven't seen since the first fraction of a second after the Big Bang. Our most powerful particle accelerators are like pop guns compared to the cannon we would need. The second wall is information. Let's say we did manage to get a signal from another universe. What would it even look like? If that universe has different physical laws, the information might be completely incomprehensible to us. It could be a blast of static, it could be a form of energy we don't have the tools to detect. It's like trying to play a Blu-ray disc on a record player. The information is there, but the hardware is fundamentally incompatible. And the third, and perhaps biggest, wall is the very nature of observation. Our entire understanding of the universe is built on light, on the electromagnetic spectrum. We see things because photons travel from an object to our eyes, but as we saw with the brain world idea, light is probably stuck to our own universe. If you can't get light from one universe to another, you can't. See it in any conventional sense. You are trying to look into a room with no windows and no doors, and the walls are infinitely thick. So, what does this all mean? When we put it all together, the picture is pretty clear. Seeing a parallel universe directly, like looking through a window, is almost certainly impossible. The laws of physics, as we understand them, seem designed to keep universes separate. But indirectly, maybe. It's a long shot, a very, very long shot, but there are a few faint possibilities we can test. We can keep scanning the cosmic microwave background for strange patterns. We can keep smashing particles together at the LHC, looking for energy that disappears in just the right way. We can keep mapping the gravity of the cosmos, looking for influences that can't be explained by the matter we can see. These are not guaranteed paths to discovery. In all likelihood, the CMB cold spot is just a random fluke. The missing energy at the LHC will never show up. Dark matter will turn out to be some new kind of particle in our own universe, not a shadow from another. This is the most probable outcome, but imagine for a second that it's not. Imagine that tomorrow a team of astronomers announces they have found undeniable proof. A pattern in the sky that could only be caused by a cosmic collision. Or physicists at CERN announce they have definitive evidence of extra dimensions. What would that mean for us? It would be the single most profound discovery in human history. It would rewrite everything we thought we knew about our place in the cosmos. For our entire existence, we have looked up at the sky and felt a mix of awe and loneliness. We are on this tiny rock in a vast, dark, and seemingly empty universe. The discovery of a multiverse would change that. We would know we are not alone, not in the sense of finding aliens, but in a much deeper sense. Our entire reality would be revealed as just one possibility among many, one page in an infinite book. It would raise a whole new set of questions. If there are other universes, are there other versions of us? This is where the many worlds and bubble universe ideas diverge. In the bubble multiverse, the other universes are likely to be very different, with different physical laws. Life might not be possible there. There would be no other you, but in the many worlds version, there would be. An infinite number of yous making every possible choice. How would we react to that knowledge? Knowing that every mistake you made was a success for another version of you. Knowing that every tragedy you suffered was avoided in another branch of reality. It's a philosophical and psychological minefield. It can be liberating or it can be terrifying. It could make our choices seem less meaningful, or it could give us a strange sense of connection to all these other selves we can never meet. The search for other universes is not just about finding new worlds, it's about understanding our own. The questions that lead us to the multiverse are the biggest unanswered questions in physics. Why is gravity so weak? What is dark matter? What happened before the Big Bang? The multiverse isn't a theory someone just made up because it sounded cool. It's a potential answer to these very real puzzles about our own reality. So, could we see into a parallel universe? No, probably not. The universe seems to like its privacy, the walls are high, and our tools are small. But we can listen at the wall, we can look for the faintest of tremors, we can search for the subtle shadows that might hint at something on the other side. That search is worthwhile even if we never find anything. It pushes the boundaries of our knowledge. It forces us to think in new ways about space, time, and reality itself, and it reminds us that the universe is far stranger and more wonderful than we can possibly imagine. We live on one small island of understanding in a vast ocean of mystery. We don't know if there are other islands out there. But it is in our nature to build the boats and set sail anyway. We may never reach another shore. But the journey itself will show us just how incredible our own world truly is.